This is going to be a series of 3 videos that look at trigonometric modelling. In this one here we're going to consider a fictional frog population which we're going to model by a sine function where the maximum number of frogs of 170 occurs at day 75 and the minimum of 90 occurs at day 115. So the first thing we want to do is find A, which in this case is the amplitude, and that is just the difference between the maximum and the minimum halved. So we want to do 170 minus 90 divided by 2, which is going to give us 40. And then we want D, which is the displacement from the horizontal axes, which is the average of the minimum and the maximum. So we can either do 170 plus 90 divided by 2, which is going to give us 130. But you might also notice that it's always going to be the amplitude plus the minimum, or the maximum minus the amplitude. I then find it easiest to work out the period, and the period is just the time from the maximum to the maximum, or the minimum to the minimum, or from one same point to another. Well, from here I know the time from the maximum to the minimum is going to be 40 days. But we're going to have to double that to get from maximum to maximum. So that's actually not going to be 40 days, it's going to be 80 days. And then we can work out B. B is 2 pi divided by the period. So that's going to be 2 pi over 80, which is just going to give us pi over 40. And finally C, which is going to be our horizontal shift, so that's going to be minus time to the maximum, well that's 75 days, minus the quarter of a period, well the period's 80, so it's minus 20. So that's going to give us 55 minus 55. Now we have the value of A, B, C and D. We can just put those back into the function, so we get P equals 40 sine B, which is pi over 40, T, and then it's plus C, so that'll be minus 55, and then it's going to close another bracket there, plus D, so that's plus 130.